Swayam Prabha. Digital India. Educated India.
So, we continue with our discussion on file system management. In this second lecture of this module, we shall be looking at some details about how a file system is stored in a secondary memory system like the disk, and what are the different kinds of data structures that are required for this purpose. Okay. So, we start by talking about something which is very important in any operating system, some kind of file naming conventions. See, here there are two things. When you store some data on secondary storage, we store them as files, that is understood. And so that we can retrieve our files later, we store them by giving some names. And also you know there are so many different kinds of files. You can have a program file, you can have a text file, you can have a document file, image file, video file, you can have an archive file, so many different kinds of files are there. So, in order to distinguish between these different kinds of files, most of the operating systems, they have the provision of providing something called extensions. But of course, not all operating systems, most operating systems I am saying, they use some file name and file extensions. So, let us see. In the file naming convention, a file is identified by two things, the name of a file and some kind of an extension. Let us take an example, myprog.c. Myprog is the name, this is the name of my file, and .c indicate the extension, this is my extension, and this extension indicates what kind of file it is. Okay. Now, there are numerous kinds of extensions which have been used, these are the conventions, a few of them I am showing here. Some common extensions, .jpg or .jpeg, these are used for JPEG image files. In this context, let me tell you there are other formats of image files as well. There is something called .png, .gif. These are also different formats of storing images. Then when you want to store some audio files, some music or any other thing, MP3 is a very popular format. This is a music, and MP3 stands for MPEG layer 3 audio format. And any file that has an extension .txt, it is expected that it is a normal text file where the data that you store in the text file are simply ASCII characters. There are no special characters in the file. Okay. And as you all know, this PDF is a very popular and common way of sharing files among different platforms and users. So, you can create a PDF out of almost anything, a document, an image, a multimedia document, anything you can create a PDF file and you can share. Similarly, there is another format called PostScript file. This was designed mainly for use with some sophisticated printers. Okay. And .c indicates that it is a C source program file. For a C++, you use either .c++ or .cpp. These are the kind of extensions that you use. For a Java program, you typically use .java and so on. And for a compressed file, if you are compressing a set of files using the zip tool, zip archive generator, then the extension will be .zip. There are other compression methods also available. There is a tar, in that case it will come .tar, .rar. There are many other compression methods also available, right. So, these are some of the file naming convention and extensions that are used by the operating systems. Okay. Now, the second important thing is that this is an important data structure. Later on we shall see with reference to some very specific operating system like the Linux, how these are actually stored, but conceptually let us see. We know that when you create a file, we create folders, under a folder you create a file. Now, in the first generations of operating systems, the operating system supported only single level directory. There was a root directory under which all files were stored. Here A, B, C, D 4 names are shown. So, all files were stored under a same root directory. So, the idea was that there was something called a directory. So, I am talking about how inside what is happening very briefly I am trying. In the directory there will be entries for the different files, and each file there will be some kind of information as to where it is stored. Because you need to locate the data of the file, right, on the disk. In the directory you will have some information about the file names, all right, and in addition where it is stored. But nowadays in the modern operating systems, you know that you do not have a single level directory. You can create subdirectories also. Inside a subdirectory you can create more subdirectories. So, you can have in general a hierarchical multi-level directory structure, but it starts with a root. It starts with a root directory. See, in this diagram the squares are used to denote directories or subdirectories, and the circles are used to denote files. So, you see under root directory I have created 3 directories. These are user level, users can create these. Let us say one I am giving name A, name you can give any name B, C. Under this you can create other directories. These are not names, just indicative, A, B, C are just indication. So, under this C you can create more subdirectories, and under the directories and subdirectories finally these files are getting stored. Okay. So, this is how we store files in a modern day computer system. So, suppose you want to create some important document, I create a new folder, under that folder I create my files like that. Okay. Fine. Now, one important thing is that when you create these files under folders and subfolders, you have to specify the name of a file sometimes. Suppose you are writing a program to access a file, you have to specify the path name, or you are giving a command copy, rename, move, you have to specify the name of the file, but the file may not be in the current folder, it may be in some other folder. So, you have to specify the path name of a file, so that the file can be uniquely you can say uniquely identified or uniquely specified. Now, let us talk about the convention that is followed in Unix and Linux. In other operating systems like Windows, it is very similar, slight difference is there. Now, in Unix or Linux, whenever you specify the path name of a file, there are 3 ways you can specify. One is you can specify the absolute path name. Absolute means, see, any file system starts with a root, and root is typically denoted by slash, and under root you can create other folders and subfolders. Okay. So, when you say absolute path name, what I am trying to say is that I specify the path name starting from the root. So, an example is here, the first example here. I say this slash in the beginning indicates that I start with the root. Under root there is a folder called home. Under home there is another folder called USR. Under folder there is another folder Amit. Under Amit there is docs. Under docs there is a meeting, and finally under meeting you have the file report.pdf, and between these folders and subfolders use the slash as a separator. This is how you uniquely specify where the file is located. Okay. Now, there is a concept of a current working directory. So, you can also specify the file path with respect to the current working directory, which you typically specify by a dot. Like the root you specify by slash, the current directory, see current directory you can change directory, there are commands like cd or chdir using which you can move from one directory to the other, one folder to the other. That will be your current working directory. Now, from your current working directory you can specify the path. For example, here your second example shows that the dot in the beginning indicates that you are indicating the current directory where you are. From there is a folder called programs. Under that program, under that folder there is a file called bubblesort.c. Okay. So, if you use a file name with respect to current working directory, you have to specify less thing, because otherwise you have to specify from the root the whole thing up to the current directory, then the remaining thing. But the dot allows you to specify from the current working directory. And the third thing is that, let us say in Unix or Linux, whenever you log into the system, you normally log in to your home directory. There is something called home directory. Under home directory you can create your folders, you can create your subfolders. So, the third method is with respect to the user home directory. Now, your home directory you can specify by this symbol tilde, this tilde symbol. The third example specifies that with respect to your home directory, this tilde, there is a folder called travel. Under travel there is another folder called photos. Under photos there is one file, this 12352.jpg. So, like this you can specify the names of a file uniquely. Okay. So, the examples that I have taken are very much similar to Linux or Unix. Well, in Windows there is one small difference, like here as separator we use this forward slash, but in Windows you specify reverse slash, reverse home, reverse doc, like this. So, there are small differences, otherwise the concept is very similar. So, now in a Linux system, suppose I start with a root. Under root there is a folder called home. Under home there is a folder called Amit, there is a folder called Subir, there are many folders. Under Amit there can be a folder called doc, there can be a folder called prog. Under Subir also there can be a folder called doc. Under doc I store a file, let us say a.txt. This is a file I am storing. Under Subir here also I can store a file with the same name. There is no problem. I can store two files in the same name as long as they belong to two different folders. Now, these two files, they can be uniquely specified by specifying their file names. For example, if I specify from the root, for the first one the path will be home Amit doc a.txt. So, the unique path from the root is specified. Similarly, from the second one the path will be home Subir doc a.txt. So, there is no confusion. If I specify correctly the path name, I am telling the operating system exactly how to locate the file. So, even though the same file is located in two different places, I am telling clearly that which file I want to access. Okay? Fine. Now, all operating systems, they have some basic facilities or commands to create and manage directories and folders. So, I am here giving the examples with respect to Unix and Linux, because in Unix and Linux you can create a command window and from there you can type, or a terminal, from there you can type the commands. In Windows mostly it is based on a graphical user interface. By clicking the mouse you can do most of the things, but what examples I am showing here is that you open a terminal window, a command window, and from there you type the direct commands to the operating system. So, when you want to create a new directory, a new folder, the command is mkdir, make directory. So, when you say mkdir some name, what it does? It creates a new directory with the name that you have specified under the current working directory. So, wherever you are now, the new directory will be created under that. So, the new directory is created under the current working directory. Using mkdir, you can create multiple directories in the same command also, multiple folders, dir A, dir B, dir C. I want to create 3 new directories, so I can do it in a single command also. Delete a directory. Here I can use the rm command, remove. See, using rm I can also remove individual files, like I can write rm a.txt, then the file a.txt will get removed. But if I use this -r flag, it means recursive. Whatever I have specified, music clips is a folder. So, all the files under music clips and all the folders even under music clips, everything will get removed. So, the entire directory will get removed. Okay. Now, I can also rename a directory or a folder. Now, in Unix or Linux, the command for rename is move, mv. You give a move command, old name, new name. This same command can be used to rename a file also. Renaming a file, renaming a directory, the command is the same, mv. And as I said, you can use some commands to change the current working directory. You can use either chdir, change directory, or the short form cd. There are some special shortcuts also. If you write cd dot dot, double dot means the parent directory. So, wherever you are, whichever folder, you move one level up. If you write cd dot dot slash again dot dot, move one level up, again one level up, like that you can specify anything you want. Okay. So, in this way you can specify, you can move to any folder, any directory you want. Fine. Now, talking about files, generally when you create a files, depending on the contents, what you are storing in the file, you can classify or categorize. The file, the structure of the file can be different, like in the simplest case it can be an unstructured file. Unstructured file is treated as just as a sequence of bytes. Bytes can be anything, not necessarily the ASCII codes, it can be any bytes. You think of an image file. Normally the image file is unstructured. You do a zip file is unstructured. But of course, there are some headers in this file which contain some information. So, if I ignore the header, the remaining part is unstructured. But some operating systems support some record structure. Again, this is not supported by all operating systems, all file systems. In a record structure, whenever you store some data in a file, you store them as records. In each record, there can be multiple fields. See, this is similar to how you store some information in a database. You store some information in the form of a table. Say for the students, you store roll number, name, age, other information, that is one record. So, you store record for each student, and if you say that my file is a structured file, I store the information in a record wise fashion, and depending on the kinds of records we are seeing, the size of each record can be fixed or it can be variable. Like for example, you can also store information about students, what are the courses the students are going through, the names of the courses. See, some of the students may be doing 2 courses, some student may be doing 3 courses. So, the size of the records may be variable, and this file will span multiple lines, one line per record. Now, I am repeating, normal operating systems do not support this record structure. If we have a special software, you can store data like a database in the form of this record structure. Now, you can have other complex structures also. Let us take an example. Suppose you create a file using Microsoft Word, you create a PDF file, you compile a C or C++ program, generate an executable file. But if you open these files using a text editor, you will find that there are a lot of some peculiar symbols which are coming. Those are non-printable characters, these are said. So, this is not a text document, and they are formatted, there are some special characters inserted which has some special meaning. Okay. So, this complex structures give some meaning to the file. For example, in a Microsoft Word file, certain parts of the document needs to be shown in bold, some in italics. So, those special characters inside will tell all those things. Now, the thing is that who decides on the file type? Like I open using a text editor, I cannot understand anything. The operating system of course will understand the file type. Typically by how? Operating system will identify it typically by looking at the file extension, this is one thing, and also by looking at the file header. There are some special information stored in the file header which also can tell what type of file it is, and also most importantly the program that accesses the file. Like an MS Word file, I am not supposed to open using a text editor, I am supposed to open it only using Microsoft Word. Similarly, PDF file, I want to open it only using a software which can view PDF file like an Acrobat reader or something. Okay. So, those programs know how to read and interpret the file. Okay. Fine. Now, let us again we take examples for Unix and Linux. For other operating systems, there is something similar provided. So, when you create a file, you can also provide some kind of security in terms of how the file can be accessed. Now, in Unix or Linux, when you say how it can be accessed, there is something called mode. Mode can be one of 3, it can be read, write or execute. Suppose you have created a text file, it can be only read or write, it cannot be execute, right. So, you give the access right for reading and writing. Not only that, on the system, operating system classifies 3 classes of users: the owner, the person who has created the file, and owner is part of a group. Under that group there can be multiple users. All the owners of that group, members of the group, and public, everyone else. Now, read, write, execute, these are specified by 3 bits, read, write, execute, read, write, execute, and read, write, execute. There will be, for every file there will be 3 bits for the owner, 3 bits for the group, 3 bits for the public. So, you can specify how you want this file to be accessed. Okay. Like for example, I am giving some see this read, write, execute, these are 3-bit numbers. These are normally expressed in octal, 0 to 7. 0 0 0 means 0 and 1 1 1 means 7. There is a command to change the mode of a file, and only the owner of the file or the super user can change this mode. Like let us take an example, change mode, this is the command. I specify in octal what mode I want, 700. 700 means this is 7, this is 0, this is 0, and this is the name of the file. So, what I want, I am giving read, write, execute permission to the owner, but no permissions to the others. But if I would allowed the other to read my file, then I can give 111, 100, 100. So, in octal it would be 744. Similarly, another example 600, where 6 means 110. So, I am giving only read and write permission, not execute permission to the owner. So, like this we can specify access rights to the files, so that accidentally you cannot carry out any other kind of operations even if you want to. Okay. Now, the other thing is access methods of a file. So, when you create a file on a secondary storage, let us say disk. So, inside a disk there is a file. I have stored a file in a disk. Now, the question is how do I access the data in the file? Now, as I told you, the file can be large, there can be several blocks in the file. These are blocks, block number 0, block number 1 and so on. And these blocks can be stored somewhere in the disk, need not be in one place. The first access method is called sequential access. Sequential access, as the name implies, you have to read the data block by block sequentially. There is no other way to access the file. So, unless you have finished reading block 0, you cannot read block 1. Once you have finished block 1, you can go to block 2. Okay. Now, sequential access, see, means you can always open a file, you can start reading from the beginning, that will be sequential access. But you also have a facility to seek and go to anywhere in the file and start reading from there. So, it is not strictly sequential. But if you have a storage medium like a magnetic tape, well, you have seen the cassette recorders, right? Magnetic tapes are very similar. When you play a tape, it starts from one end of the tape and goes to the other end. You cannot jump to the middle. You will have to proceed sequentially and go through the entire tape to wherever you want. So, magnetic tape was something where inherently it was sequential access, right. But in disk it is not so. You can have direct access, like if you know which track number, which sector number your data is in, you can directly go to that track, directly go to that sector by using the seek and rotational delay. This is what is meant by direct access. That means, if I want to access block number 2, if I know where my block number 2 is, I can go directly there and start accessing it. And index sequential access is something similar, which says that there is something called an index file. I maintain some kind of an index. Like in the back of a book, you have an index, right? You want to search for a keyword, you see which page number, you go to that page number. Index file contains for every block where exactly in disk it is stored. So, you directly get the address in the disk, you first consult the index, then you go to the block where the data is stored. So, it is somewhat similar to direct access, you can say, but you have a separate index block. Now, another thing, let me tell you, this was important. Some of you may be knowing that when you have a hard disk in a system, normally the hard disk is divided into several partitions. When you divide a hard disk into partitions, each of the partition will be running a separate file system. So, as I said, first thing is that it can divided into several partitions, and each partition can have a separate file system. The important thing to note is that these file systems need not be of the same type. One may be some file system under Linux, one may be NTFS under Windows, one may be some file system created under Mac OS, and so on. They can be of all different types. So, let us say you have a disk 1, under disk 1 you have two partitions, partition A and partition B, you have two different file systems in these two partitions, and you can have some partition, this is also possible, some operating system also allow this, multiple disk, they can be mounted one after the other to create a single large partition, that is also allowed in most operating systems. Okay. Now, the point to note is that when I say it is a partition, it means it is running some file system. If there are 4 partitions, there will be 4 file systems. Okay. Now, in Linux, as we will see that normally there is one file system called swap, where for virtual memory the swap space is maintained, and the others are the user file systems, whatever you create. Okay. Fine. Now, let us come to what is there in a file system. A file system has to contain, I said file system is nothing but a data structure which keeps track of all the files, all the directories, all relevant information. So, what are the basic information it needs to store? First thing is this, what kind of file system it is, whether it is NTFS or ext or what kind of file system it is, and what is the total size of the file system, how many gigabytes or how many megabytes, whatever it is. And secondly, it must keep track of all the directories and files. Somehow you must store information about all the directories and all the files in the file systems. And for all the files, you need to keep track of where exactly the data in the file are getting stored. The disk blocks where the data are stored, you have to keep information in some way, and of course, lastly the free space information, where in disk the free space are currently available, right. So, these are some of the things which are essential in a file system, you need to keep track of these. Now, importantly, let us first look into this. When I create a file, I need to give space on the disk where the file data can be stored. Let us first look into this, how exactly in a disk the disk blocks are getting allocated, they get allocated, because I can have a file which can be pretty large, and this file may require multiple blocks to store the data. So, the question is where in disk these multiple blocks will be allocated. So, broadly there are three methods, we shall be discussing these one after the other: contiguous allocation, linked allocation, indexed allocation. Let me tell you, most of the operating system today they follow the third approach. Let us start with contiguous allocation. So, what contiguous allocation is? It is very simple, just like contiguous allocation in memory management that we discussed, that the entire program is loaded in a contiguous location in main memory. Here in a similar way, each file occupies a set of contiguous blocks. So, in the disk there is something called logical block number. Each block on the disk is given a number 0, 1, 2, 3, 4, depending on say sector wise, track wise, sector wise, surface wise, some ordering will be there, but the blocks will be given some number, logical block number. So, when I allocate space for a file, I must allocate contiguous block number. Let us say block number 7 to block number 10, 7, 8, 9, 10, these 4 blocks will be required. Now, because the blocks are contiguous, reading and writing operations will be faster typically. So, this first point is understood. Normally, it will give better performance during read and write operations. And secondly, keeping track of the file becomes easy. You need only to keep track of the starting block number from where it is starting, and how many, or the ending block number, or how many blocks are there in the file. So, as I said, 7 to 10, 7 is the starting, 10 is the ending. So, you can either keep like that, or you can keep starting location is 7 and length is 4, 4 blocks are there, right. But this method, although it is very simple to implement, there are some obvious drawbacks. Suppose a file is pretty large, you need so many blocks, but you may not find that many contiguous blocks on the disk, it may be difficult. And secondly, normally when you create a file, when a program is running, there are a lot of write operations on the file, the size of the file grows with time. So, if you say I am doing contiguous allocation and the file is growing, you can be in trouble. So, how do you make a file grow, because there may not be space after that file, already something else is stored. So, should you move the file entirely to some other location and then again do the write? That is very expensive. Okay. And secondly, because you are talking about contiguous allocation, exactly similar to memory management where you talked about contiguous allocation, you can have external fragmentation. There can be small sequence of blocks, free blocks which are available, but no large enough contiguous blocks that can accommodate a large file that may be available. So, sometimes you may need to perform a very expensive operation, disk compaction, and during disk compaction all the other operations have to be suspended, because while disk compaction is going on, no other user programs can be running, they have to be stopped altogether. Okay. This is one. Pictorially you can show it like this. Let us say we have a very simple example, let us take block size is 512 bytes, simple example. So, whenever you want to access some particular byte in the file, let us say the logical address, you divide it by 512, take the result after division and also the remainder, that means you can write like this. So, Q will be the block number and R will be the offset within that particular block. So, block to be accessed will be from the starting address, you go to the qth block, that will be the block you want to access, and inside that block the offset or displacement, that is r. So, you look into the diagram on the right, your file directory may be like this. Here we store information about 1, 2, 3, 4, 5 files. So, we are saying that the first file is starting from block number 0, its length is 2. So, you see count is stored here and here. TR is starting from 14, length is 3. So, 14, 15 and 16, these 3. Mail is from 19, length is 6, this 2, 3, 4, 5 and 6, this is mail. List from 28, it is 4, 28, 29, 30, 31, and F from 6, it is 2. So, it is very simple. In the directory you need to store information only about the starting block and the length or the ending block, whatever. But as you can see, there will be small holes that can be created in between, that is external fragmentation, that is the drawback. Next, let us come to linked allocation. So, linked allocation, instead of keeping the blocks in contiguous location, what you do, suppose I have a block, this is a particular block of the file. So, I stored the data, but at the end I keep a little space to provide the address of the next block, that means like a pointer. So, I am taking out a few bytes from each block and I am storing a pointer which will contain the address of the next block. So, I am maintaining some kind of a linked list of blocks. So, here the blocks need not be contiguous, it can be anywhere in the disk. So, we are storing a linked list of blocks. So, as I have just now said, each block will contain a pointer to the next block and the last block will contain a null pointer. There is no more blocks after this. Because you can utilize any free block wherever it is available, there will be no external fragmentation, which means you do not need any disk compaction, just like contiguous allocation. But the operating system must keep track of the free blocks list. But there are some few drawbacks, is that problem of reliability. Of course, this problem is there for any method you can think of. If somehow due to some disk corruption, see, disks can get corrupt, some part of the disk might get some error. See this, suppose this link gets somehow destroyed. So, you will lose the information that which is the next block. This can lead in loss of data. Suppose you have some data stored, maybe you have lost some part of the data, but you are trying to recover as much as possible. But if you lose a link, you really do not know where the other links are. Okay. And the other drawback is, suppose you are trying to access the 10th block. So, from the starting you have to follow the link, access the disk 10 times to go to the 10th block. So, locating a particular block may need several disk accesses. So, access in general can be very slow. Okay. This is one drawback. Let us see diagrammatically. Here in the directory I am only showing one particular file, let us say a file called zip, and there are two entries in the file, start and end. End is optional, end you may or may not keep, but start is important. So, I am saying the starting block number is 9. So, from here I go to block number 9. As I said, in every block there will be data and there will also be a pointer that will be pointing to the next block. So, in 9 there will be a pointer which will be pointing to the next block, which is 16. So, after 9 the next block is 16. 16 will contain a pointer that the next block is 1. After 16 it is 1. 1 will contain a pointer, next block is 10. After 1 it is 10, and after 10 it is 25. So, 25 is the last block. So, either you make 25 point to null or keep the end block number also, so that you know when you reach 25 there is nothing more after this. So, as you can see that the data in the file can be stored in random block numbers, so that you do not waste any space through external fragmentation. Okay? This is simple linked allocation, but the drawback is that you may have to traverse so many links to locate a particular data in the file. So, the mapping similarly, if you know the values of q and r, starting from the starting block you have to traverse q blocks, so many disk reads are required, and once you reach the qth block you can find the offset or the displacement into in that block, that data you want to access. Okay. Fine. Lastly, let us look at indexed allocation. Now, in indexed allocation the idea is that you do not maintain a linked list, rather you maintain something called an index table, and every file has its own index table. Each file has its own index block of pointers. What does this index table contain? For example, for some file, let us say I have ABC, ABC is a file. This is the index table corresponding to ABC, and in this index table I am storing information that there are 5 blocks in the file, and I store the block addresses in the index table. Does not contain anything else, just the block addresses. So, you directly access and you can go to the block directly. So, you see you again, if you do that same thing, LA equal to 512 into q plus r, given a logical address in the file you want to access, if you know that you want to access the qth block, you directly consult the index table and go to the qth row, and from the qth row you directly go to the qth block, that you do not have to traverse through so many disk accesses just like a linked list. You have to access the index table once and the final block once, 2 accesses, right. So, each directory entry, as I said, will contain a pointer to the index block, just like I showed here. And Unix or Linux, we shall be discussing this later. It follows this method in a slightly more complex way. There is something called index node or inode, we shall be looking at later. What is the exact structure of the inode? Okay. And pictorially, let us see what happens. Look at the directory. Here again I am considering that same file zip. Here one particular block in the disk stores the index. Let us say it is block number 19. And what does block number 19? Say block number 19, I am showing the snapshot of the content here. It contains the sequence of block numbers in that file, 9, 16, 1, 10, 25, minus 1 means not there, those are invalid. So, there are 5 blocks. So, 9 the first block is 9, second block is 16, third block is 1, fourth block is 10 and fifth block is 25. But you are not maintaining any linked list, you are simply maintaining this index file. and for every disk access you need two accesses to the disk, one to access the index file, other to access the actual data in the file. Now, see, in this method one problem you can envisage, that what if the index block gets corrupt? If your block 19 gets corrupt, your entire information about the file is lost, right. So, see, all these methods has some vulnerability in case there is some problem in the disk, there is some corruption in the disk. So, one way out is that many operating systems, what they do, they maintain something similar, but they maintain a shadow copy of the index files. The idea is that if an index file gets lost due to some disk corruption, the other copy may still be accessible. You can recover the file by accessing the other duplicate copy. Okay. This is generally the idea. So, with this we come to the end of this lecture, where we have towards the end we have started to look at some of the actual ways in which the disk data gets stored corresponding to the different files. We discussed contiguous allocation, linked allocation and indexed allocation. But one thing we have not discussed as yet, we shall be talking about this in the next lecture, that how the free block list is maintained by the operating system. Well, the idea is similar. You can also maintain a linked list of all the free blocks that the operating system can maintain. Whenever a file needs to expand or a new file is getting created, you need to create a space for a new file, you can allocate one block from the free block list. So, all these things we shall be discussing in the next lecture. Thank you.